So coming to our next question. So the isothermal process at temperature T0, the work done, temperature T0 means that temperature means it is a isothermal process. The work done by the gas going from B to C is double the work done by the gas on going to A to B. Means this work done is double of this AB work done. The pressure of the gas state C is, this is a net question, so this one multiplied by P0. How much we have to calculate the pressure of the this point, means we have to calculate this PC. Okay, so you can first read the question carefully, then pause the video, think about it and solve. Think what is coming on your mind. I am explaining gradually. Okay, so mainly we know that we given what is given is that this is an isothermal process. Isothermal process Boyle's law. So and given is W of AB into 2 equal to W of BC. Okay, now we have to calculate the pressure of the C point. Okay, so as it is a isothermal process at constant temperature, so we can apply this equation. We know nRT ln work done minus nRT ln AB, final point, initial point, V2 by V1 we wrote. So final point we don't know, this is we should take it as VB, this is VB, this is BC suppose, and this one is V0 given already in the question, into 2 equal to minus of nRT T0, not T0 ln final point is BC, initial point is VP. So we can get from here that this one will cancel, ln VB by V0 equal to ln VC by VB, this is 0. So VB square, okay, we want in form of BC, so it will be helpful to BC. We want to calculate the PC, this one target is PC, so for that BC one, so BC equal to, BC is here. Okay, we can write here from VB by V0 equal to VC by VB, so VC equal to VB square by V0. Okay, I have to we can use the lower space as well. So we get the BC point, BC value, VB square by V0, and now you can see that this curve 3 points are there, means 3 points, this is given P0 V0, this one given PB VB, and this one is PC VC. So all will satisfy that our isothermal curve, means we can write as PV equal to constant from Boyle's law. So we can write that all will satisfy as all 3 points are present in that curve, so all will satisfy this equation. So P0 for point A, P0 V0 for point B, PB, VB, 4 point C, PC, VC. P0, V0 for point A. Point B, the pressure is given actually P0, V0, and the pressure is given here P0 by 2 into VB. Okay, and here VB equal to, why I wrote this, because I want the VB value here. P0 value is given P0 by 2, means sorry, PB value is given P0 by 2 in the question, but I want the VB value because I have to put here to find the VC value. So VC equal to P0, P0 cancel, 2 into V0. Okay, so I will put here, let me use another pen. So VC equal to VB equal to 2V0, 2V0 whole square by V0. Well, what will be the answer? 4. For V0. Okay. Now we have to again use this equation. So we can write here that P0 V0 equal to PC into VC. So PC equal to P0 V0 by VC. So P0 V0 by okay, I miss one point. So this 2 is there. This 2 is there. Sorry guys. Here 2 is there. 2 is there. So it will come here. And from here we can write VB by V0 a whole square equal to VC by VB. So from here we can write, you can see, I think. So VC equal to VBQ by V0 square, VBQ by V0 square, VC is equal to. So here we have to BC equal to BB. BB value is 2B0 whole cube by square 8B0, right? 8B0, that will be value. Sorry for the mistake. So we'll put the value of VC 8B0. B0 cancel. So we have to put the value here multiplied by P0. So P0 will be there 1 by 8 equal to 0.125. They told, I think, up to 2 decimal, na? So they told up to 2 decimal, so we will write the value as 0.13. 125 means 13. Okay, that will be the answer. I think you understand. If you didn't understand, rewind the video. I explained very easily and you know all these things. Okay, now we will proceed to our next questions. So coming to our next question, please read the question that a gas follows the equation of state P plus A by Bm square into Bm equal to RT. The value of A is given. We have the fugacity of the gas at 100 atm and 298 Kelvin each in atm. So they want to know the value of fugacity at the atm unit. The pressure is given P the temperature is given T and the pressure constant is given here. So I take this question to inform you about the formula of the fugacity. So fugacity equal to P e to the power minus A into P by R square into T square, right? Just remember this formula and the problem will be solved. So what is the formula? F equal to F e to the power minus AP into R square T square. So P, the value is given 100 into e to the power minus A value is given 1.7 atm liter square mole inverse into P, that is 100 atm. R you have to take 0.082 because in above atm is there. So to calculate you have to take the R value as a atm liter atmosphere, liter L atm mole inverse K inverse whole square into 298 Kelvin whole square. So liter square will cancel, atmosphere square will cancel, mole inverse will cancel, K inverse. Okay, everything will be cancelled and the fugacity unit will be the unit of the this pressure atm. So after calculating this I get the answer. I got the answer around 79.53. Sorry, I don't want to waste time, that's why I am, but don't be lazy, please calculate, because I calculated. Don't follow the master, because master already calculated. I don't want to waste time because already the video is very long, so I calculated it. Please, but make that habit using that gate calculator. Install that in your mobile, gate calculator, and calculate by that. Practice with that, so it will be easier for you in the examination. So the answer is 79.53 atm. Okay, let's proceed to the next question. So coming to the next question, a gas following the equation Pb to the power n equal to constant work obtained from going P1 V1 to P2 V2 is this one. This one is given and the value of n. We have to calculate the value of n. This is also an add question. After that it I will do a MSQ. Okay, let's try this question. The only given data is this one, the work done, and the following equation is this one. So let's write this equation. Pb to the power n equal to constant. So take it as C. And we have to calculate the work done, right? So W equal to minus dW equal to minus P delta B. Okay, okay, so we can replace here P equal to C by V to the power n, right? So if we integrate both sides, let me replace first. dW equal to minus C by, okay, C, take integration 0 to W V1 to V2 1 by V to the power n, right? I replace the value C by V to the power n here, dV. Okay, so here W equal to minus C V to the power minus n plus 1 by minus n plus 1 V1 to V2. Okay, okay, so replace this minus C V to the power minus n plus 1 this is a constant, so this is 1 minus n, okay, we will replace first V2 to the power n minus 1 minus V1 to the power minus n plus 1. Okay, am I going right? Check, you also derive. Okay, so okay, we can replace this C with PB to the power n, so we can put there, right? Means if we multiply this C with V2, we can write P1 V1 equal to P2 V2 equal to C. For this case we can write P1 V1 P1 V1 into V1 minus n plus 1, right? If I multiplied this minus with that minus, right? So I multiplied this minus with that minus, that will be plus. This one is, we have to calculate the value of n, so we have to write here n. I forget to write here n. I multiplied this with it minus P2 V to the power n V to the power minus n plus 1 by 1 minus n. So we will get from here, sorry, P1, this one will get P1 P2 V2 by 1 minus n, right? B to the power n minus B to the power n will be cancelled. So we are getting this work done. W equal to P1 V1 minus P2 V2 by 1 minus n, and already our question in question given is 3 P1 V1 minus P2 V2 equal to P1 V1, this one I am writing this one, so it will cancel. So 1 minus n equal to 1 by 3, n equal to 1 minus 1 by 3 equal to 2 by 3 equal to 0.67. Right, because I forget to tell that we have to take up to 2 decimals, so 0.67. so this will be the answer. Okay, let's don't waste time, let's move to our next question. So coming to our last question, that is an MSQ. It is about Joule-Thomson experiment. We have to tell that which one, how many of this one is correct. So as you know that Joule-Thomson coefficient is mu jt equal to delta T by delta P at constant H, means it's a isoenthalpic. So as you can read that experiment performed on the adiabatic condition and possesses an isoenthalpic, both are correct. You know these things, we have to just verify these two statements. Let's read this statement. When the inversion temperature is higher than the experimental temperature, the gas cools down on expansion. They are asking that inversion temperature is higher, when the inversion temperature is higher than the experimental temperature, the gas cools down on expansion. So what is the formula of the inversion temperature? That is Ti equal to 2A by RB, this one. Okay, we can write here 1 by Cp 2A by RT minus B. Okay, so if expansion occurs, that means delta P is negative. Higher pressure to lower pressure, final minus initial, so delta P is negative and delta T, okay, let's not confuse. Suppose mu jt greater than 0, is value is greater than 0. Gradually we have to calculate. Okay, relax. So that is 2A by RT minus B greater than 0. (2A by RT greater than B), 2A by RB greater than T. And 2A by RB means Ti, that is T, means inversion temperature is greater than T when it is greater than 0. If the delta P value is negative because of the expansion and as it is cooling, so there just understand that this we are getting this value this value positive. When Ti is greater than T and as expansion occurring, this one is negative, delta P. So the gas has to be cools down, means this will be negative, then it will satisfy. See, cools down means T2 minus T1 equal to negative, final temp cools down, delta T is negative, it is not, it is cooling, so it will satisfy. C, minus 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 positive, this one is also positive when Ti is greater than T, means this one is correct. Understand? See, I did it means back calculation. See, firstly I did mu Jt greater than 0. I supposed it is greater than 0. I supposed. So I replace this with that equation. This is greater than 0. Then this one is greater than B. So I replace the B and T. So 2A by RB is the inversion temperature. So inversion temperature will be greater than T, experimental temperature. This T is experimental temperature. So this one is positive, and we know delta P will be negative because it is expansion occurring. Expansion means higher pressure to lower pressure. So how we calculate the delta P? Final minus initial. So lower minus higher means delta P will be negative. So delta P must be negative to get positive mu Jt. So this will be correct. Fourth option, negative value of Jt coefficient corresponds to the warming of the gas on expansion. Warming of gas on expansion. How will we explain this one, sir? Tell me with your knowledge, tell me. For the fourth option is wrong, so we get 3 options correct. So tell me the fourth option. Let me drink some water. So again same thing, you can tell from this my explanation, previous explanation. Okay, so again expansion on occurring, expansion means delta P will be negative, delta P will be negative, and negative value of Jt, already they told this is negative. So they told, let me write again. Delta P is negative, and they told this one is also negative. So this one negative, this one we have to get negative. So delta T should be positive, means warming. Simple, na? Should be positive. So all the options are correct. So I think you understand all my questions, my explanations. If you don't, please comment. I'll try my best to explain that in next video. I think this video series, it is take it as a practice for GATE examination. I explain some MCQs, some deep tricky questions, some net questions. It will help you. Please share. It depends on you. If you like that video, you can share to your friends, or it's up to you. So I think it will be very helpful to you. So happy learning and keep learning. Thank you.